Okay, guys. So, guys, basically in today's class, we are going to discuss our new topic that is called VLAN. Okay. So, before start VLAN, first of all, we need to understand what are the challenges we have right now and how VLAN is solving our problem. Getting my point? First of all, we need to focus on the challenges. When we are able to understand the challenges, automatically you guys will able to understand the VLAN. Okay. Now, to show you the challenges, I present couple of topologies in front of you. Try to focus on these topology, guys. For example, with the first one, when you see this topology, we have a two client. One is FedEx and second one is Facebook. Clear? So this is present. This is located on this tower. This is located here. This is located here, and this is located here. And all the four routers are connected with the as a device who is located in the data center. Fine. Generally, guys, in a company or in a real time network, whenever we provide a network to any client, generally we are providing the different network ID to the different client. Clear? For example, to the FedEx, we assign 192.168.1.0 network. For Facebook, here we assign 192.168.3.0 network. Here we assign 4.0 and here we assign 2.0. So guys, on every client have a different network. Clear? Now, in previous class, guys, I already explained you one thing. At layer number 3, we have a device called router. At layer number 2, we have a device called switch. If you want to make communication possible from one network to another network, you need router. If you want to make communication possible inside the same network, you need switch. I mean L2 switch. Fine. But right now we have a different clients and different clients have different network. So if I implement here L2 switch, am I able to communicate? Answer is no. We are not able to communicate with each other because your switch is not able to perform or switch is not able to forward your packet from one network to another network. So that's the reason I choose a router. So if you have a router, you can make communication possible. There is no problem. This is the first thing. Second thing, try to understand. I already explained you about the packet flow, right? In the packet flow, I already explained you about the ARP, right? So there are how many types of ARP, guys? There are two types of ARP. ARP request and ARP reply. There are two types of ARP. Clear? What is the use of ARP? The use of ARP is to find out the destination device MAC address. Destination device MAC address. Getting my point, everyone? Yes or no? This is clear to all of you. Now, if you guys know, I already told you ARP request always be broadcast and ARP reply always be unicast. Right? So ARP request is broadcast and ARP reply is unicast. Now try to understand. For example, from if this router to this router, if you try to ping, this will generate the first of all ARP request, and this is the broadcast packet. This packet will reach on the router. What router will do? First of all, try to understand whenever router will receive, whenever this is the router. Please remember these things. Whenever router receive any broadcast packet, router is not going to forward your packet from one network to another. Router never forward your broadcast packet from one network to another. Clear? So if, for example, that is the router, this is the PC, and this is the PC. If you try to ping from this PC to this PC, it will generate the packet. It will generate the packet. It will generate, for example, ARP request, and that is the broadcast. Packet reach onto the router. But what I told you, This broadcast packet is not going, this router is not going to forward your packet from here to here. Here you are using, for example, 10th network, and here you are using, for example, 20 network. So in this case, what you need to do, this ARP request will find out the MAC address to your default gateway, to your default gateway instead of destination. Clear? For example, that is 10.1. Here IP address is 10.10. Here you assign 20.1 and here you assign 20.10. And if you are pinging from 10.1 to 20.1, if you are pinging 10.1 to 20.1, the source IP will be, guys, 10.1 and destination IP will be, guys, 20.1. Getting my point? But when this PC will generate the ARP request, which packet, guys? ARP request, source IP will be, guys, 10.1. Clear na? And destination IP or target IP will be, guys, default gateway IP address, that is 10.10. This is the default gateway. This is the default gateway. Clear na? So whenever this PC wants to ping this one, this PC must know default gateway MAC address. Getting my point? For example, if this is you and you wants to reach HR, but you try to reach the HR, but this is beyond. You are not able to reach the HR. What you will do? You will reach out to your manager, right? And this is the task of your manager to coordinate with the HR and let you know, right? In the same way, this is your manager and this PC can't directly reach this PC. So this PC directly reach to the manager, and this is the task of manager to make the communication possible from here to here. Getting my point? In the same way, guys, in the networking, same way, guys, here. Getting my point, everyone? So if from here to here, if you are trying to ping, it will generate the ARP and it will find the MAC address of this interface, that is called default gateway. But again, that is not possible if you are using the L2 switch. This is not possible if you are using the L2 switch. This is the first thing. And if it is generating the R packet is reaching here, and this router is not forwarding your ARP packet towards here, 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 like this. I told you ARP is the broadcast packet. ARP is the broadcast packet, but the router is not going to forward your packet towards the every interface. Why every interface? No, router is not forwarding. It means router is a layer 3 device. So at layer number 3, we have a router that break the broadcast domain. What is, guys? Broadcast domain. Now again, I am using one new word for you. What is, guys? Broadcast domain. What do you mean by broadcast domain? Try to understand, everyone. For example, that is switch. With this switch, this is the interface, this is the interface, this is the interface, and this is the interface. Total how many interfaces are there, guys? Total 4 interfaces are there. With every interfaces, there are, for example, 4 PCs there. For example, this is you, this is your manager, this is the director, and this is the VP. With the same switch, everyone is connected here. For example, if you want to share some information with your manager, what will happen, guys? You will generate the ARP request because your PC don't know what is the MAC address of your manager PC, right? It will generate the ARP request. ARP request is the broadcast packet. Packet reach onto the switch. Switch open this packet and switch will find, oh, this is the broadcast packet. What switch will do? Switch will forward your packet. Switch will forward your packet through this interface, through this interface, through this interface. Why? All interface. But try to understand right now what is your requirement. Your requirement is you are just pinging your manager, so your packet should go like this. Why the switch is forwarding the packet on this link and this link? Is there any use? Answer is no. That is complete waste. You are wasting the bandwidth of this link. Getting my point? You are just wasting the bandwidth of this link. There is no use. That is useless, right? Because you want to directly communicate with your manager. But what is the problem here, guys? Switch When switch is receiving any broadcast packet, switch is forwarding your packet through all the interface. So now, what is the conclusion? What we can say? We can say, if we are using switch, if we are using switch, by default, all the interface, by default, all the interface is present in same broadcast domain. Domain means area, guys. Okay, so don't be confused. It means by default, all the interface of a switch is in the same broadcast domain. It means same broadcast domain means whenever switch receive any packet on any interface, I mean the broadcast packet. I mean broadcast packet. Whenever switch will receive any broadcast packet on any interface, switch will check, oh, this is the broadcast packet, and switch will understand, oh, my by default all my interface is the part of broadcast domain. All the interface is present in the same domain, same broadcast domain. So switch will forward your packet through every interface. But actually, you are trying to directly communicate with your manager. You do not need to forward your packet towards the director and VP. Getting my point? So that is the problem. You can say that is the problem. Getting my point, everyone? Yes or no? So the first, what is the first problem? First problem is broadcast domain size. Right now, we do not want every interface should be in the same broadcast domain. But here, every interface is right now same broadcast domain. Is same broadcast domain. Getting my point? So that is the first problem. Second problem is, guys, there is no logical segmentation. Yes, logically there is no any types of segmentation. For example, you, your manager, director, VP, everyone is present in the same broadcast domain. It means whenever anyone wants to share any information, your packet is going towards the every link. Getting my point? And the third problem is security concerns also. Getting my point, everyone? So, guys, that is the problem here. Clear? I hope you guys understand what is the challenges we have. Clear, guys? Understand? So, guys, basically these are the challenges we have. We have a single broadcast domain at layer number 2. So at layer number 2, whenever switch is receiving any broadcast packet, switch is forwarding that packet through every interface. But at layer number 3, there is a router. For example, there is a PC, there is a PC, there is a PC. If this PC send the any ARP request, that is the broadcast packet, packet reach here, router is not going to forward your packet, this broadcast packet towards here and towards here. No, because please remember, every interface of a router is in different broadcast domain. What, guys? Different broadcast domain. Clear? So router will not forward your broadcast packet from one network to another network. But in case of switch, switch is going to forward your packet from one network to, sorry, one from all the interface. That is the problem. That is the problem, guys. Clear? Understand, everyone? Now, see here, guys, in this topology. In this topology, if you see, again we have a same client, and every clients have different network ID. Every clients have different network ID. Getting my point? And here we are using the switch, and all the network is connected with switch here. All the network is connected with switch here. Clear? So if you, first of all, if you try to communicate, it is not possible because switch is the L2 device. Switch is a L2 device. But for example, if you are using here as a L3 switch, then you can make communication possible. But for this reason, you need to enable here, guys, routing. What you need to do, guys? Here you need to enable routing. But in this scenario, we have a same client in the different network, and here we are using the L2 switch. The answer, the question is, are we able to ping? Answer is no. We are not able to ping. We cannot communicate with each other because here all the devices are in different network, and here you are using L2 switch. L2 switch has no sense. L2 switch is not going to forward your packet on the basis of IP. On the basis of IP. Getting my point, everyone? Yes or no? Clear na? So here this is not possible. Understand, guys? Everyone? Yes or no? Tell me. Right? But if you see this topology, here we have a different client, and here all the clients are in different network, and here for example we are using any L3 switch. Here we are using any L3 switch. Then can we able to communicate if we enable the routing? If we enable the routing, then we can communicate. There is no problem. If we enable the routing, then we can easily communicate. There is a no problem. But if we are not enable the if we do not enable the routing, then in this case we are not able to communicate. I hope you guys understand. Let me show you. For example, come to this router and let me check I configured the IP address or not. Show IP interface brief. See here, I already configured 192.168.1.1. 192.168.1.1. Clear? Now go to the global configuration mode. I am writing one command, that is no IP routing. I write one command, guys, no IP routing. Why I write no IP routing? Because I want this router should behave as a end device. This router should behave as a end device. This router do not perform any types of routing. Clear, guys? Everyone? Yes or no? What I want, this router perform what? Routing. Clear? Am I audible, guys? Everyone? Yes or no? Right now, this router should not perform, guys, any types of routing. Clear? So that's the reason I write here command no IP routing. Done. So if anyone asks you this question, if I want to use any router as a end device or as a host device, what are the things we need to do? So just say, sir, we need to configure one command, that is no IP routing. Clear? Now again interviewer will ask you, tell me what is the use of IP, no IP routing command. Now then you can say, sir, when we are configuring the no IP routing command, in this case our device will behave like a host device. That device is not going to check the routing table. Our device is not going to forward the packet on the basis of routing table. It behave normal like a PC. Getting my point, everyone? Yes or no? Done na? Now, again, if interviewer will ask you, ki, hey, for example, if I want to ping from one network to another network, for example, right now on router number 7, the IP address is 192.168.4.1, and on router number 5, IP address is 192.168.1.1. Both are in the different network. So in this case, if you ping, then you can say, yes, if you are pinging from the different network and you already enable no IP routing, in this case, router again not able to check the routing table, but router will check the default gateway. What, guys? Default gateway. Please understand. Router always check the default gateway. Clear na? So in this case, you need to provide the default gateway if you are disabling the no IP routing command. Clear, guys? I hope you guys understand. If you do not configure the default gateway, then where this router needs to forward this packet? Getting my point, everyone? Understand? So for example, I write here no IP routing command. Done. And come to this router. Let me check. Enable show IP interface brief. Here we configure 192.168.2.1. Let me check no IP routing. I configure. Now let me check, do we have default gateway? So running configuration pipe section include gateway. See, I already configured here, guys, 192.168.2.10. What I configure, guys? 192.168.2.10. Arey, what I configure? 192.168.2.10. Now again, you guys have question. Okay, sir, where you configure 2.10? Where you configure 2.10? Again, see here. I will tell you now. Come to this router, guys. When I go to this router, see, guys, do show IP interface brief. See, here I already configured 3.1. Okay. Do show running configuration pipe include gateway. There is no gateway configure, guys. So running configuration pipe include gateway. No gateway is there. Okay. Let me configure it. No IP routing. Clear? And here I am configuring, for example, what I configure, guys. How can we configure the default gateway on router? See here, guys. IP default gateway 192.168. We are on router number 6. Where, guys? We are on this router, right? And on this router we configure 192.168.3.1. So gateway will be 3.10. Okay. So I configure 192.168.3.10. So this is the way I configure the gateway. Now you can check. See, 3.10 is the gateway here. Clear? Now come here on this router. Enable show IP interface brief. IP address is 192.168.1.1. ठीक है. So running configuration pipe section include gateway. 192.168.1.10 is already there. Okay, done. So everyone, see here what I did. Here I configure 192.168.1.1. Here I configure 192.168.3.1. Here we configure 192.168.4.1. And here we configure 192.168.2.1. On every router we are running, guys, no IP routing. It means all the router right now behave like a normal PC. Done. So if you are writing the no IP routing command, I told you these are the router, and by default behavior of the router to check the routing table. What is the by default behavior? By default behavior of a router to check the routing table. But right now you already disable the routing. It means this router is not going to check the routing table. Clear? So if this router will not check the routing table, if you ping from here to here, and this is in 4.1 network, and this is in, for example, 3.1 network, both are in the different network. So in this case, where this router needs to forward the packet, this router perform the A and D operation, and after performing the A and D operation, this router will check, find, yeah, you are pinging different network that is not configured locally on my device, I don't know. So in this case, this router needs to forward the packet towards the default gateway. Clear na? So you need to configure the default gateway. Clear? So here I configure the default gateway 4.10. Here I configure the default gateway 2.10. Here I configure the default gateway 3.10. And here I configure the default gateway 1.10. But again, there is a question. Question is actually where this default gateway is configured. Where this default gateway is configured. Getting my point, everyone? Yes or no? Right? This is the switch. This is the switch. For example, I take the console of the switch. I write the command. So interface brief, for example. Show interface. For example, there is any interface. Let me check. 0 by fast Ethernet 0 by 3. Fast Ethernet 0 by 3. Interface fast Ethernet 0 by 3. IP address. I'm not able to write the IP address command, guys. I am not able to write the IP address command. When I press the question mark, are you able to see the any IP address command here? No, I'm not able to see the IP address command. We can't configure the IP address command here on switch. Getting my point, everyone? Yes or no? Right na? But when I take the console of this switch, and if I check, for example, conf t interface fast ethernet 0 by 3, interface fast ethernet 0 by 3, and if I write the command IP address, it is checking. I am able to write the IP address command. I am able to write the IP address command. Why? Why am I able to write the IP address command? But for example, if I write here switch port, exit, now I am writing interface fast ethernet 0 by 3 IP address. Now I am not able to write the IP address command. I am not able to write the IP address command. What is the reason? Previously I was able to write na on interface fast ethernet 0 by 3 IP address command, but now I am not able to write the IP address command. Why? Because I write there is a one command, that is switch port command. What I write, guys? I write switch port command. Who can tell me what is the use of switch wait command? Who can tell me what is the use of switch port command, guys? Anyone? See na, before the switch port command, I was able to write the IP address command on interface fast ethernet 0 by 3. I see I am able to write the IP address command, but after writing the switch port command, I am not able to write the IP address command. Understand? Basically, there is a command that is switch port. When you write the switch port command place your interface as a or be configure your interface as a L2. What, guys? As a L2. It means after writing switch port command, your interface will behave like a L2. Clear, guys? So it will perform the switching, not routing. It will behave like a L2. It means it will forward your packet. It will accept your MAC address, not IP address. Getting my point? Understand everyone? Yes or no? Right now. So if you want to configure the IP address on the interface, what you need to do? You need to enable the switch port. You need to remove the switch port command. Then after you can configure the IP address there.
Mm.
Understand, guys? Everyone?
Yes.
So see, now all are logical things, guys. Whatever the things we are discussing here, everything is logical. So for example, we go interface fast ethernet 0 by 3, and I write no switch port. When I write no switch port command, now see IP address. See, I am able to write the IP address. IP address. This on we are on which interface? We are on fast ethernet 0 by 3. Where is fast ethernet 0 by 3? Here, right? And here we need to configure which IP address, guys? 4.10, because for this router we configure the default gateway 4.10. Agree, guys? Everyone? Yes or no? Right? Here I am writing IP address 192.168.4.10, 255 255 255.0, and no shutdown. That's all. I hope this is clear to everyone. Done? Yes. Now, in the same way, come here, guys, on fast ethernet 0 by 4. Interface fast ethernet 0 by 4. IP address. Here we are writing IP address. What is the IP address, guys? 192.168.192.168.2.10, right? Because here on this router we configure the default gateway 2.10, right? 255.255.255.0, and no shutdown. Done. Now similarly, interface fast ethernet 0 by 2 IP address for 0 by 2, for 0 by 2, let me check where is 0 by 2. Yes, that this is 0 by 2. So on 0 by 2, default gateway will be, guys, 3.10. IP address 192.168.3.10, 255.255.255.0, and no shutdown. Exit. Interface fast ethernet, I think 0 by 1, IP address 192.168.1.10, 255.255.255.0 and no shutdown. Done, guys? Everyone, yes or no? I configure the default gateway on every interface. Clear, guys? Everyone. So what I configure? 1.10 I configure. Then we configure 2.10 we configure. Then we configure 3.10 we configure. And then we configure, guys, 4.10 configure. So these are the address we configure. 10.10 here we configure. 2.2.10, 2.10, 2.10. Here we configure 2.10. Here we configure 3.10 and here we configure 4.10. Is this clear, everyone? Yes or no? Done na?
Yes.
Okay. Now, now, for example, now if we try to ping, for example, let me enable the packet flow. For example, see, I come to this router. I am writing, first of all, I am writing so IP ARP. When I am writing so IP ARP, see this router know the ARP of 4.1. Which one? 4.1. But remove it. For example, I am writing ping 192.168.3.1. 3.1. This router generate one packet. See, what is the packet, guys? This is the ICMP packet. This is the ICMP packet. Clear? In the ICMP packet, what is the source IP address? What is the source IP address? What is the source IP address? 00000. Done. What is the source IP address? 0000. See, this packet is getting drop here. This packet is getting drop here. What is the reason? What is the reason why this packet is getting drop here? For example, go to this router. When I check here, this packet is getting drop, right? Everyone, yes or no? Are on this router, this packet is going drop, right? Okay. Yes, we are not able to ping 3.1. Where is 3.1? Here. What I did, guys, we are just trying to ping from this router to this router. Everyone, yes or no? Tell me, right? We are trying to ping from this router to this router, but we are not able to ping. When I check the routing table, show IP route, we are not able to check the routing table. Why? Because you know already we write the command no IP routing here, right? No IP routing we already write here. Yes or no? Show running configuration pipe include gateway. Do we have any gateway? Do we have any gateway? No, we do not have a gateway. So if this router, tell me one thing, if you are telling to this router ki, hey, you do not need to perform the routing because I am disabling the routing by command no IP routing. You already disable the routing here and you do not provide the gateway. So if everything is already disabled, then where this router will forward the packet? Is this possible? Answer is no. This is not possible because you already disable the routing as well as what? Default gateway as well. Getting my point, everyone? Yes or no? Tell me. Right, na?
Yes.
So you
Yes.
already disable. So that's the reason when you see the packet, for example, when you see the packet 3.1, when you see the packet, what is the source IP address? 0000. What is the source IP address, guys? 0000. Generally, when we get the 000, generally when we get the 00, when router do not have a route to forward the packet. Getting my point? And in your scenario
Mm.
right now, this router don't know where this router needs to forward the packet. So that's the reason source packet is 000, source IP is 000, and packet is getting drop here. Getting my point? Is this clear, everyone? Yes or no? Clear? Now,
Yes.
I go to the global configuration mode. I am setting the default gateway. What is the command, guys? IP default
Gateway.
IP default gateway 192.168. For this router default gateway will be, guys, 4.10. What is 4.10? I set the default gateway now. Done, everyone? Yes. Now Now I go to this router. I am writing the command ping 3.1. Now see how many packets are able to see. 2 packets are there. Yes or no? Tell me. Right? One will be the R packet. Yes or no? Tell me. Right? This is the R packet because this router don't know what is the MAC address of this device. This router don't know what is the MAC address of this device. So that's the reason this device generate which packet, guys? R packet. Now in this R packet, when you see what is the destination address? FFF. FF means that is unicast or broadcast. That is broadcast. Getting my point, everyone? Yes or no? Right na? Yes. And when you see the ICMP packet, when you see the ICMP packet in ICMP packet, what is the source IP now? 192.168.4.1. But when you didn't configure the default gateway, at that time you are getting source IP 0000. Yes or no? Because at that time this router do not know where that router needs to forward the packet. But now this router know where I need to forward the packet because you already provide the default gateway. Is this clear, guys? Everyone, yes or no? Tell me. Right? Guys, clear? Now,
Clear.
Yes, yes.
come here, R packet. In the R packet, at layer number 2, when you check the R packet, the destination address is FFF. It means that is the broadcast packet. So, see here how actually broadcast packet is treated. So, that is our main concern. See, this packet generate the R. That is the broadcast packet. Packet reach onto the switch. What switch is doing? Switch is forwarding the back to the packet where? To this router. Getting my point? It means this device send the broadcast packet. Packet reach here, and this device is forwarding back this packet towards there. But this is the broadcast packet. So when this broadcast packet reach here on the switch, so according to the rule, this packet should be broadcast towards the every interface. Yes or no? Tell me yes or no. Right? But this device is not forwarding. This device is not broadcasting the packet here. What is the reason? What is the reason? Anyone who can tell me what is the reason?
There's no default gateway.
No matter if you already default gateway, if you already configure the default gateway, but still that this is the switch. If still that is the switch, if you remember, I already told you this is the scenario. If any switch receive any broadcast packet here, switch will forward the packet here. But if you are using the router is not going to forward your packet from one network to another network. Right? Everyone, I already told you. But here this is the switch. But this switch is not forwarding the packet. Here, this device send the R packet. R packet reach here. And this switch generate the ARP reply. This switch is generating the ARP reply. I can show you. See here. Let's back. Router inbound. Inbound means this is the packet this switch receive. Right? So this switch receive the broadcast packet here. FFF. Now, outbound. Outbound means this is the packet switch is forwarding towards the router. Now see, what is the source? Source MAC address is 2103. What is the MAC address? 2103. Agree everyone? Yes or no? Tell me. Come to the switch. Show interface. This switch is forwarding the ARP reply by which interface? 0/3. Yes or no? Tell me. Right? So interface fast Ethernet 0/3. When I write show interface fast Ethernet 0/3, what is the MAC address, guys? What is the MAC address? 2103. What is the MAC address? Everyone. 2103. And here, what is the source MAC address? 2103. Is this same or different? Same? Arey, this is same, na? This is same. This is same. It means here, here when this switch is sending the ARP reply, in this ARP reply, source MAC is this fast Ethernet 0/3 interface MAC address.
Hmm.
Clear, guys? Everyone tell me yes or no. Right? When
Right.
this switch is sending the ARP reply, in the ARP reply, what is the source MAC address? Fast Ethernet 0 by 3 MAC address. What is the destination MAC address? Destination MAC address is 8E01. What is 8E01? So destination MAC address is nothing. Destination MAC address is this interface MAC address. This interface MAC address. Clear na? Understand? When you go to the here, you guys, here we are right now, we are not able to see, but yes, you can check. You can check interface gig 0 by 1. See, what is the MAC address? 8E01. Everyone, yes or no? Match na? 8E01, guys. Talk logically. 8E01. 8E01. Yes or no? Everyone. Right?
Yes.
Yes.
801.
So, what is the thing I'm trying to explain you here? When this router is sending the broadcast packet reach here, but this switch is not broadcasting your packet. This switch is not broadcasting your packet. Getting my point, everyone? Yes or no? Tell me. Right now, everyone. Now, come to this topology.
Hmm.
Come here to this topology. Now, if I, in this topology, for example, interface gig 0 by, I think 1 or 0, 0 by 0. Interface gig 0 by 0 IP address, for example, 192.168.4.1.255.255.255.0 and writing no shutdown command. That's all. Now, for example, here interface gig 0 by 0 IP address, that is router number 11 3.1 192.168.3.1.255.255.255.0 no shutdown. And here done. Here we configure the IP address. Done, guys? Everyone, yes or no? Done na? Okay. Now, for example, I come to this router. You know, right now, if you ping, if you ping from here to here or here to here, are you able to ping? If I'm asking the very basic question, if I ping from this router to this router or this router to this router, are you able to ping? Answer is
Yes.
yes. You are able to ping. I'm just asking, are you able to ping?
Yes, you are able to ping.
You
No,
are able
no,
to ping. Why? You guys are not able to ping, guys. Here
because
we have a switch, and
switch.
these are the routers. These are in the different network, guys, not in the same network.
Yes.
These are in the different network. And I already told you in the first class, if you guys are using the switch, you can't make communication possible between the different network. Getting my point? If you are using the router, then yes, you can able to ping from one network to another network. Getting my point?
Yes.
But if you are using switch, you can't. Is this clear, guys? Everyone, yes or no? Done? Everyone, clear now?
Clear.
Okay.
Yes.
Here on this router, on these router, we are not going to assign any types of default gateway. We didn't configure. How can you check, guys? Show running configuration pipe include gateway. See, is there any gateway configured? No, there is no gateway configured. Done. But for example, here I am writing ping 255.255.255.255. Who can explain me? 25, what is this IP address? Who can explain me? What is this IP address? I told you. This is the reserved IP address, guys. Right? Everyone, yes or no? This is the reserved
Default.
IP address. And this IP address is called broadcast address. Which address, guys? Broadcast IP address. Getting my point,
Yes.
everyone? Yes or no? That this is the broadcast IP address. Please remember. Clear? Understand? For example, if I am writing 10.0.0.1, this is the unicast. This is the unicast. You can assign to any device this IP address. There is no problem. But if I ask you 255.255.255.255, that is the broadcast IP address. Clear, guys? Everyone? Yes or no? Clear? Understand?
Yes.
So if I write here this one, 255.255.255.255, am I able to ping? Am I able to ping?
Yes.
See, where you are able to ping?
Locally.
I'm not able to ping here, guys. For example, go here. Ping 255.255.255.255. I'm not getting the response. I'm not getting the response.
So which means does not default gateway.
Okay, I will explain you this one also. Okay, wait for a minute. Okay, come here. But I hope you guys understand here, guys. Here, when this router send the packet reach here, but this router, sorry, this device is not forwarding your packet. Guys, the reason is, if you remember, here on every interface, you already configure one command, that is switch port command. Yes or no? Tell me. I-
Yes.
Yes, at the initial state, I configure one command, that is switch port command. Yes or no? Everyone agree? Right now? Right? Yes. On every
Yes.
interface, you configure the switch port command, guys. Yes. So, running configuration, interface, fast Ethernet, 0 by 3. Basically, this switch is not supporting this command, but yes, you configure the switch port command. So, running configuration, there you can check. There you can check. See, on every interface, you configure this command. Which command? No switch port. If you do not configure the no switch port command, are you able to configure the IP address? Answer is no. You can't configure the IP address, and I already prove you. Yes or no? Everyone tell me. Right? Everyone, right
Yes.
now, you can't configure the IP address. But after writing the no switch port command, you are able to configure the IP address. Why? What is the reason? Because now your all the interface behave like a L3, not L2. It means now your switch is behaving like a L3, means router, not switch. Clear, guys? Everyone tell me yes or no. Right? So if this
Clear.
switch is behaving like a router, what is the use of router? I already told you. Does router forward your broadcast packet from one network to another? Answer is no. Your router is not going to broadcast your packet from one network to another network. That is not possible. So that's the reason when this router is sending the ARP broadcast packet reaching here, but this device is not forwarding your packet here. This not forwarding the packet here, guys. Clear, guys? Everyone tell me yes or no. Understand? Yes?
Yes.
Yes.
Yes. That is not forwarding your packet. I hope this is clear to all of you, everyone. Done? Yes, guys, tell me. Yes, na? This is not possible. So that's the reason. Here it generates the packet, but your broadcast packet is not going towards this link, this link, this link. But for example, if we discuss about the L, if we discuss about the switch, if we discuss about the switch, if we discuss about the switch, see here, that is the switch. And here you configure what IP address? 192.168.4.1, 2.1, 3.1, 1.1. Do you configure any default gateway here, guys? No, you do not configure any default gateway. Yes or no? Tell me, guys. Right now,
No.
I do not configure any default gateway. But yes, all the device, on all the device, we configured no IP routing because these are the end device. Yes or no? So running configuration pipe include gateway. Is there any gateway? No, there is no gateway. Right?
Gateway.
Okay. Now come here 11. Here I am writing the same command. No IP routing because I want this device should behave like a host device, end user device. No IP routing. Okay, done. Now, still, here we have a 4.1 and here we have a network 3.1. Both are in the same network or different network? Both are in the different network. Agree? Everyone tell me, right? Right now,
Yes.
if I write the command, ping 192.168.3.1, am I able to ping? Tell me.
No.
No. Why?
Because a switch doesn't forward different
Exactly,
network.
because on this router you already write first command, that is no IP routing.
Yeah.
And by the help of this command, you are telling this router, okay, hey, you do not need to check your routing table first. And second thing, this router will tell you, hey, if you are telling me do not check the routing table, could you please tell me the other path? You are telling, no, I am not giving you the default gateway also. Then where this router will forward the packet? There is no path. Yes or no? Tell me. Right? This router do not have any path where this router needs to forward the packet. Getting my point? Even I can show you. See here. When I write the command 3.1, it generates the ICMP packet. But in the ICMP packet, when you check, what is the source? 0, 0, 0, 0. I told you what is the meaning of 0, 0, 0. It means this device do not have any path to where this router needs to forward the packet. So that's the reason you are getting 0, 0, 0, 0. Is this clear, guys? Everyone, yes or no? Tell me. Right? Okay.
Yes.
Now, but for example, if I am writing here command ping 255.255.255.255, this is the which packet? That is the broadcast packet. Yes or no? Tell me. Right?
Yes.
That is the broadcast packet. In this packet, source IP is 192.168.4.1. This is the source IP. Source IP means, guys, this is the IP address of this router where you configure 4.1. And what is the destination? Broadcast. Array, this is the broadcast na packet. Yes or no? Right? At layer number 3, that this is broadcast, and at layer number 2 also this is broadcast. Array, yes or no? Right, everyone? Right na? So on both layer, this packet is the broadcast packet. Clear? But see, when this packet reach onto the switch, this switch receive which packet? Unicast, multicast, or broadcast? This switch receive the broadcast packet. Now see what this switch is doing. What this switch is doing? This switch is forwarding your packet here, here, and here. Yes or no? Everyone, tell me. Right?
Yes.
Yes. But come to the previous scenario. Come to the previous scenario. In this topology, when this router send you the broadcast packet, does this switch forward your packet here, here, here? Answer is no.
It's a
But
different
here,
network.
this is no, this is not the solution. In this topology also we have a different network, and in this topology also we have a different network. The solution is, the exact answer is, here in this topology we do not have a switch port. We configure no switch port command, right?
So,
But here
so
this is the switch, and here I do not write the no switch port command. It means all the port is called switch port here, guys. What is switch port? Getting my point? Everyone, tell me yes or no. Think logically. Whatever the things I am telling you, I am showing you. Getting my
okay.
point? Everyone, yes or no? Right? So previously here we configure no switch port command, so we can configure the IP address. And after writing the no switch port command, I am telling to the switch, hey, please behave this switch like a L3 switch, not L2 switch. But here I didn't configure anything. It means all the ports right now is behaving like a L2 switch. And what I told you, if you have a L2 switch, if you have a L2 switch or L2 port,
It
this
means it's
will behave
configured
like a, this will, all the ports will be in the same
network.
broadcast, no, broadcast domain, same
Oh,
broadcast domain. But if you have a L3 port, in case of L3 port, all the port is not in the same broadcast domain. Every port is in different broadcast domain. Getting my point? Everyone, yes or no? Tell me. Right?
yes.
Yes. So this is the problem. I hope now you guys understand what is the exact problem we have. Clear, guys? So if we are using the switch, we have this problem. By default, for example, let's suppose now this is the different client. This is the FedEx and this is the Facebook. And if, for example, this guy wants to ping FedEx guy, both are in the same company, both are is the part of same client. The
Correct.
packet should go like this, na? Yes or no? Right? Packet should go like this. But when this packet will reach on switch, what switch is doing? Switch is forwarding packet here also, here also, here also. Do you need to forward the packet here towards the Facebook? Answer is no. That is illogical. That is illogical. Why you need to forward the packet towards the Facebook? If you want to make communication here between the FedEx, then what is the use to forward the packet towards the Facebook? You are just wasting the link. You are just wasting the bandwidth of this link. Yes or no? Everyone, tell me. Right? Everyone.
Yes.
Yes. We are just wasting. So that's the reason. That is the problem at layer number 2. That is the problem if you guys are using the switch. Getting my point? For example, here, come to this topology. In the real-time company, generally we have this type of topology. For example, that is different client. That is, for example, FedEx. That is, for example, Zoom. That is, for example, LinkedIn. That is, for example, Facebook. These are different client. And you know, every clients have same network or different network. Who can tell me? Every clients have different network ID. Yes or no? For example, if
Yes.
you are using here 192.168.1.0, here you are using 2.0, here you are using 3.0, and here you are using 4.0. Every clients have different network ID. Getting my point, everyone? Yes or no? Right? But for example, here this is the L2 switch. This is the L2 switch. This is the L2 switch, and this is the L2 switch. And by the help of this L2 switch, you connect here all the end devices. That is not the problem. That is not the problem. But try to understand. Try to tell me one thing. If you want to make communication possible here, definitely you need any L3 device. Yes or no? Right? Yes, we need L3 device. We need L3 device. Getting my point, everyone? Yes or no? Tell me. Right, na? We need L3 device. Without L3 device, you are not able to communicate between the different networks. Yes or no? Tell me. Right? Yes, guys. Right, na? But if anyone is thinking, ki sir, tell me one thing. For example, here we have a different client. Is it possible if I purchase 4 different switch for every different client? Yes, you can. But do you think company have so much budget to purchase different hardware for different client? Answer is no. Answer is no. It means what you need to do, you need to, this is the, physically this is the one hardware. Physically this is the one hardware. But you need to divide this physically hardware into logically. How, guys? You need to divide this physical hardware into logically. Getting my point, everyone? Yes or no? Tell me. Right? Yes, we need to divide this logically. And we can divide this hardware logically by the help of one concept that is called VLAN. By the help of VLAN. Now again you guys will think, ki, sir, how you are telling this one? I am telling this one. See here, for example, if you have a beautiful switch, and for example, you have here, here, like for example, different clients computer. What you will do, for example, you are telling ki, hey, this one, these three are belongs to, for example, Zoom. These two belongs to, for example, LinkedIn, and these three belongs to, for example, Facebook. So you have a two option. One, you purchase 3 different switch, assign one switch to Zoom, assign one switch to LinkedIn, and assign one switch to Facebook. But that is not the logical thing. But what I will do, I have only one switch. I will divide this I will divide this one switch into 3 logical switch. I will divide this one hardware switch into 3 logical switch. See how? I will divide by VLAN. I will create VLAN number 1, VLAN number 2, VLAN number 3. I will create 3 VLAN. I will assign VLAN number 1 to Zoom. I will assign VLAN number 2 to LinkedIn. I will assign VLAN number 3 to Facebook. It means all the user who is the part of LinkedIn is also the part of VLAN number 1. And all the user who is the part of LinkedIn will also the part of VLAN number 2. And all the user who is the part of Facebook is also part of VLAN number 3 now. So you just create a group. VLAN is just like a logical group. Getting my point? Everyone tell me yes or no, right? So this is the one group, this is the group number 2, and this is the group number 3. Understand, everyone? Now, what will happen? For example, try to understand the scenario, guys. Try to understand. For example, here any PC is connected. Here any PC. Here on every port, for example, any PC is connected. For example, this PC wants to ping this PC. Or for example, if this PC generate any broadcast packet reach onto the switch. But what I told you about the switch, what is the feature of the switch? Whenever switch will receive any broadcast packet, what switch is doing? Switch is by default forwarding the packet by every interface. Agree? Yes or no? Tell me, guys. Right?
Yes.
Everyone. Right? Yes. But after creating VLAN, switch is not going to do this one, guys. Switch is not going to Do this. Now when any broadcast packet will reach here on this port, switch will check, I am receiving this packet on this interface. Now switch will check, my this interface is the part of which VLAN. Now switch will find, oh, this interface is the part of, for example, VLAN number 2. Now this switch will check, there are how many ports? There are how many ports that is configured on VLAN number 2? Then this switch will find, oh, this port and this port, these are the two port which is the part of VLAN number 2. These are, for example, VLAN number 1. These are, for example, VLAN number 3. Now what switch will do? Switch will forward your packet through all the interface which is the part of only VLAN number 2. It means switch will forward your packet towards here and here only. Not going to forward your packet here, 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 here. Is this clear, guys? Everyone tell me yes or no. Clear? Everyone. What is the benefit of VLAN? See here. So, for example, in this scenario, how many clients do you have here? 2 clients, FedEx and Facebook. How many clients you have, guys? You have 2 clients, FedEx and Facebook. For example, let's suppose, just change the scenario. For example, right now you have a 4 client, FedEx, Facebook. For example, that is Zoom, that is LinkedIn. How many clients do you have now? Total 4 client? Yes or no? I will create 4 VLAN here. I will create how many VLAN here, guys? I will create total 4 VLAN here. Clear, guys? Everyone, yes or no? Right? Guys, tell me yes or no. Right, na? For example, here one more. For example, here one more PC, one more. That is FedEx. That is, for example, FedEx. That is Facebook. For example, that is Facebook. That is, for example, Zoom. That is also, for example, Zoom. That is, for example, LinkedIn. That is for also LinkedIn. Now see the scenario. I will create how many VLAN, guys? I create VLAN 4. For example, VLAN 2, VLAN 3, VLAN 4, and VLAN 5. I will assign VLAN number 2 to FedEx. I will assign VLAN number 3 to Facebook. I will assign VLAN number 4 to Zoom. I will assign VLAN number 5 to LinkedIn. So for example, now if LinkedIn is sending any broadcast packet reach here onto the switch, what switch will do? Switch will check, I am receiving this packet on which interface? Switch will check, find I am receiving this packet on this interface. And this interface is the part of which VLAN, guys? For LinkedIn, what is the VLAN? VLAN number 5. Switch will forward this packet through all the interface, which is the part of only VLAN number 5. So this interface is only part of VLAN number 5. So this switch is only forward your packet through this interface, not through everyone. Getting my point? Everyone tell me yes or no. Right now? But right now in this scenario, when this device is sending the broadcast packet reaching onto the switch, and switch is forwarding the packet through all the interface. That is the problem. Because, for example, FedEx is communicating with the FedEx. Then why you are sending the packet towards the Facebook? Is there any need? Tell me, is there any need? Answer is no. There is no need. There is no need. Getting my point? Everyone tell me yes or no. Clear, guys? Everyone. Do you guys understand? Tell me. Right? Now, see. Now the next thing is how we configure the VLAN. How we create the VLAN onto the switch. See. Open the switch. Go to the global configuration mode. Enable global configuration mode. I am writing VLAN. After that, I press the question mark. See, what is the range of VLAN, guys? 124094. That is the range of VLAN. 124094. That is the range of VLAN. Clear, guys? Everyone, yes or no? Right? For example, I am writing VLAN number 10. After that, if you want to set the name, if you want to write the name of any VLAN, you can write name. For example, I am writing, creating this VLAN for the FedEx. I am writing FedEx. Clear, guys? Everyone, yes or no? Right? Exit. Right? Exit. Again, I want to create VLAN 20. And I want to name here, guys, this is for Facebook. I'm writing Facebook. Exit. So this is the way you can create the VLAN. So see how many VLAN I created, guys? 2 VLAN I created. One is VLAN number 10 and the name of that VLAN is FedEx, and I create VLAN number 20 and the name of that VLAN is Facebook. Clear, guys? Everyone, yes or no? Clear? Tell me, guys. I'm audible?
Yes, it's clear.
Okay, cool. So this is the way I created. Now again, how can you check my VLAN is created or not? What is the command? First command is show VLAN. If I write show VLAN, if I write show VLAN, see here, VLAN number 10, the name is FedEx. VLAN number 20, name is Facebook. This is the two VLAN I created here. And by default on switch, VLAN number 1 is by default there. You can't delete this VLAN, you can't edit this VLAN, you cannot do anything to this VLAN. Clear? So by default, VLAN number 1 is configured onto the switch. And by default, every port of the switch is the part of which VLAN? VLAN number 1. By default, every port of your switch will be the part of VLAN number 1. Clear, guys? Everyone, yes or no? Right? So I created, guys, 2 VLAN, and these 2 VLAN are VLAN 10 and VLAN number 20. Now, next step is, after creating the VLAN, you need to move the port into that VLAN, because right now, how many ports are there? Fast Ethernet 0 by 1, 0 by 2, 3, and 4. Every port is the part of VLAN number 1. Now what you need to do? You need to configure these two ports, VLAN, this port and this port, in VLAN number 10, and this port and this port is in VLAN number 20. How can you do? How can you do? Simple thing. Go to the switch. So first command, how can you check the VLAN, guys? I told you what is the command. So VLAN. Clear? Understand? Or there is one more command. So VLAN brief. This is the command also you can write. So there are two commands. So VLAN brief or so VLAN. Now go to the global configuration mode. In global configuration mode, for example, I want to move fast Ethernet 0 by 0. Sorry, 0 by I think 1. 0 by 1 into which VLAN, guys? VLAN number 10. So you have to write interface fast Ethernet 0 by 1. After that, you have to write switch port access VLAN 10. This is the command, guys. Switch port access VLAN 10. Exit. So when you move the VLAN, see na, this port goes down and it will take 30 seconds and it will automatically up. Clear, guys? Yes or no? Done. Now 0 by 4. Again, same way you need to move 0 by 4. How can you write, guys? Interface fast Ethernet 0 by interface fast Ethernet 0 by 4 switch port access VLAN number 10. Exit. How can you check? Again, same command. So VLAN brief. I write so VLAN brief. Now see, when I write the so VLAN brief, see, in VLAN number 10, FedEx, how many ports are there? Fast Ethernet 0 by 1 and fast Ethernet 0 by 4. Both ports are now part of VLAN number 10. Clear, guys? Everyone, yes or no? Clear? Now, next two port are, guys, 0 by 3 and 0 by 2. 0 by 2 and 0 by 3. These two ports I need to move in which VLAN, guys? VLAN number 20. Then how can you move? How can you move in VLAN number 20? Clear? Now see, again, same way you need to follow. Go to the interface fast Ethernet 0 by 2 and move it. 0 by 3 and move it. This is the first way. But if you want to move both ports by single command, you can do. For example, go to the global configuration mode, right? Interface. For example, if you want to move both ports in VLAN number 20 by single command, you can do. The command is interface range fast Ethernet 0 by what is the port number, guys? 0 by 1 and 0 by 4 we already did. So 0 by 2 and 3 is pending, right? So fast Ethernet 0 by 2, then space hyphen 3. Clear, guys? Everyone? Yes or no? Done. Now I am writing switch port access VLAN and then writing 20. Exit. Now see, show VLAN brief. See, I hope now you guys are able to see FedEx. Both port is 0 by 1 and 0 by 4. VLAN number 20 Facebook 0 by 2 and 0 by 3. Done, guys? Everyone? Yes or no? Done. So basically this is the way we configure the VLAN and this is the way we can move the port into that VLAN. Done, guys? Anyone here who do not understand? Is this clear? Done? Okay. Now, for example, we are on this device. Enable. We are on which device, guys? This one. I am writing here ping 255.255.255.255. It generates the packet, right? This is the unicast or broadcast. Who can tell me? That is the broadcast packet. Yes or no? At layer number 2 as well as at layer number 3. Done. Packet reach onto the switch. What switch is doing? What switch is doing? Guys, what switch is doing? See, it generates the packet. Packet reach onto the switch. This is the broadcast packet. But before VLAN, when any broadcast packet was reach onto the switch, what switch was doing? Switch was forwarding your packet like this. Yes or no? Everyone? Right?
Yes.
Right. But after creating the VLAN here, and I move this one and this one in VLAN number 10, and this one and this one in VLAN number 20, what happened actually? What the magic happened here? Guys, nothing magic happened. This is the one hardware switch, but I create this hardware switch into two logical switch, or you can say I create here two groups. One group is for VLAN 10 and one group is for VLAN 20. Done, everyone? Yes or no? Tell me fast. Clear? So when this device is sending any broadcast packet, packet is reaching onto the switch. Now switch is checking, hey, I am receiving this packet on fast Ethernet 0 by 4. And this is the broadcast packet. No matter that is the broadcast, unicast, any packet. Switch will check, I am receiving this packet on fast Ethernet 0 by 4 and 0 by 4 is in VLAN number 10. So if this is the broadcast packet, I need to forward that packet through all the interface, which is the part of VLAN number 10. And this interface is the part of VLAN number 10. So this switch is forwarding your packet towards the VLAN number 10 only. This switch is not forwarding your packet towards here. Getting my point? Everyone, yes or no? Tell me fast. Clear?
Yes.
Yes. See, I hope you guys understand the concept of VLAN and why we use the VLAN and what is the exact use of VLAN, how we configure the VLAN and how we move the ports in the VLAN. Yes or no? Tell me, guys. Right? For example, here I am pinging. This is in VLAN number 20. Packet reach onto the switch. Switch forward the packet towards the VLAN 20 only. Switch forward the packet towards the VLAN 20 only. Clear? Even you can add, for example, any PC here. Any PC here. For example, let me connect this PC like this. Connect this PC. Clear? Whatever the IP address configured, no matter. Okay. This is interface. This PC configured on which interface, guys? 0/6. Okay. So interface fast Ethernet 0/6. Switch port access VLAN 10. Switch port access VLAN 10. I move this PC in which VLAN, guys? In VLAN number 10. Are you done, everyone? Yes or no? Right? Come here. This is 0/5. Interface fast Ethernet 0/5. Switch port access VLAN 20. Exit 0/5. That is 0/5, and this port I move in VLAN number 20, guys. Anyone here? Anyone have any doubt? Clear, guys? Everyone? Yes or no? Right? For example, I am on this router and I am pinging, for example, I am pinging again 255.255.255.255. It generates the packet. Packet reach onto the switch. What switch needs to do? Who can tell me? Switch forward this packet through all the interface which is the part of VLAN number 10. Switch forward the packet through all the interface which is the part of VLAN number 10. I configure this port in VLAN number 10, na? Yes or no? Everyone, right? So when this switch is receiving the packet on this interface, switch is checking. I am receiving this packet on 0/4, and 0/4 is the part of VLAN number 10. So switch is forwarding this packet through all the interface which is the part of VLAN number 10. So switch forward the packet here and here. Getting my point, everyone? I hope this is clear to all of you. So guys, this is all about the VLAN, how we configure the VLAN, and how we move the VLAN, how we move the switch ports in particular VLAN. I hope you guys understand, everyone.